this is the homework helper for Chapter 5, Section 5 in the 8th grade textbook entitled Similar Figures. So let's go ahead and start off with question 1. They're asking us which triangles are similar. So remember, the first thing we have to prove when we've got similar triangles is that the angles match up. So if we look at what we've got here, we've got a 30, 60, 90 on this triangle on the left. Here's a 45, 45, 90, and this one's a 30, 60, 90. So we know this guy, just based on the angles, can't match up with anything. So the only thing that could potentially match up would be these guys here and here. All right, now, we want to match these up and orient them the same way. So the 30 degrees, we're going to make this match up by redrawing this triangle here on the right side. So I'm going to resketch this. Put the 30 out here at the right, just like that one's drawn. Put the 90 here at the bottom left, and put the 60 up top here. Now, as we go from the 30 to the 90 in the drawing, we see that that's marked at 5.2. As we go from the 90 to the 60 in the drawing, that's marked at 3. And as we go from the 30 to the 60 in the drawing, that's marked at 6. So now we can try and prove that these triangles are similar. A couple different approaches here. We can do the fraction technique like we've done in the notes, or we can just look at the common multiplier here. Look at the left sides. To go from this triangle over here to this triangle over here, 3 to 6, means I'm multiplying by 2. Remember, they have to be proportional, meaning that same multiplier now has to work everywhere else. Well, if we look at these top sides, 6 to 12 would be multiplying by 2. And if we look at the bottom sides, 5.2 to 10.4 is also multiplying by 2. So since multiplying by 2 works all the way around, we have two similar triangles. So we have SRQ similar to this triangle over here. Now it's a matter of writing it now the correct way. If you think about how we wrote congruence, remember we wrote those based on the angles. When we went from 30 to the 90 to the 60 when I said SRQ. You've got to do the same thing here. Go from the 30 to the 90 to the 60. So the 30 was Y, the 90 was Z, and the 60 was X. So that's triangle YZX. If you have a different order here, you have a different order here. You just want to make sure you flow around the triangle in logical order and again, match up those angles. Okay, a photo is 12 inches wide to 18 inches tall in number 2. So the width on top and how tall it is on the bottom, and they're telling us it's 12 and 18. They want us to now shrink that photo down so the width is now going to be 9 inches, and they want us to tell how tall the new picture would be. So I'm going to write my second fraction, and remember when we write this other fraction we have to write it the same way. So since I have a width on the top, I've got to write a width on the top. So that 9 is going to go on the top because it's a width. What I'm figuring out is how tall. So remember, when we're doing these questions here, the results have to be proportional. So I'm going to check the one diagonal, 9 and 18. 9 times 18 is 162. So this other diagonal with 12 and X also has to make 162. So I'm saying to myself, what am I going to multiply by 12 to get to 162? Well, if I do 162 divided by 12, that'll give me the answer, and that's 13.5. And that's, of course, in inches because, again, our units are consistent. If the question is all about inches, it's not all of a sudden going to change to yards. It's still going to be in inches. All right, let's go ahead and take a look at number 3. It says an isosceles triangle has a base of 20 centimeters and legs measuring 36 centimeters. How long are the legs of a similar triangle with a base measuring 50 centimeters? So a little sketch here. What they're saying is this bottom side here is going to be 20 of my triangle. And then the other two sides, the sides that make it isosceles, remember that means the two sides are the same, are each 36. And then what they're going to do is they're going to make a bigger triangle. How do I know it's a bigger triangle? Well, now it says the base is supposed to be 50. And we're supposed to figure out how long the legs are going to be, the two sides that are the same. Well, Remember, you can find a common multiplier here, but to go from 20 to 50, we might not see that very clearly. So we can also write a fraction. And remember, all you're going to do is you're going to throw a fraction bar in your drawing. All right? What you want to use here is either the 36 and 20 like that, or 36 and 20 like that. You don't want to use 36 and 36. Why? Because think, you're looking at the left and the right side. Well, if I come at the left and the right side over here, I have nothing and I have nothing. I can't solve a proportion when I'm missing two pieces of information. I can only solve out the proportion when I'm missing just one piece of information. So I can compare the 36 and the 20 to this side and 50, or 36 and 20 to this side and 50. Pick one. Based on what I've already drawn, I'm going to compare it to this side here, which I'm going to call x. Realize it doesn't matter really which one you pick because these two sides are going to be the same. So this is the same as this. So 36 over 20 equals x over 50. Cross multiply now. On the diagonal with 36 and 50, the result is 1800. So on the other diagonal with 20 and x, I have to get 1800. So I'm saying to myself, what am I multiplying by 20 to get to 1800? Well, you all know that 2 times 9 is going to give me the 18, and I need another 0 in there, so that's got to be 90. And indeed, 20 times 90 is 1800, so x has to be 90. The missing sides on my isosceles triangles have to measure 90. All right, we'll do one more and we'll go ahead and take a look at question number 6. It says Eric is drawing a picture of his school's basketball court. The actual basketball court is 84 feet long and 50 feet wide. Then he's going to draw the court, a scale drawing, and the length is going to go down to 21 inches. And they want us to find the width. So if I'm finding here the width, notice what happens here. When I write this other fraction, all right, 21 inches for the length, notice my unit consistency. I'm putting length on the top, so length's on the top. This is what I don't know, but look at the actual units. Feet, feet, and then all of a sudden it goes inches. Can't do that. You've either got to go all feet or all inches. We know there's 12 inches in a foot, and 21 inches probably isn't going to play all that well for me. So what I want to do here is convert these all into inches before I solve. So I'm going to take those feet measures and multiply them by 12. And when I do that, find out that this is really 1,008 inches for 84 feet. And 50 feet is the same as 600 inches. And now I'm going to write this other fraction, 21 inches, and some mystery figure, which we'll call x, which is what we're solving for. So remember, the diagonals have to be the same. So the one diagonal is 600 times 21, which is 12,600. Big number. So the other diagonal also has to make 12,600. So I'm saying, what am I going to multiply by 1,008 to get to 12,600? Well, that's a good calculator question, but works out pretty nicely actually. 12,600 divided by 1,008 is 12.5. 12.5 times 1,008 also gives me 12,600, which is now how I know I solved this correctly. So mystery width, when I do the drawing at 21 inches long, is 12.5 inches.